Welcome, welcome, welcome. Welcome to Google Cloud's digital conference, Let's Talk AI. I'm Tony Lusk, customer engineer at Google Cloud. Today we're going to be talking about getting AI off of your product roadmap and into your workflows. We have Googlers on standby to answer any questions you may have live, so please just click on the icon on your left and ask away. I'm pleased to be joined today by Val Fontana, our AI Global Practice Lead here at Google Cloud. So without further ado, Val, the floor is yours.
Thank you very much for that warm introduction, Tony. So I want to start by just sharing with you how Google uses AI in our own products. And you see it in some of our everyday products, right? From products like YouTube, Gmail, Google Maps. You even see it in driverless cars and AlphaGo. This AlphaGo is very interesting because, so remember, AlphaGo is a machine that beat the world Go champion. One of my favorite AI applications at Google is Google Translate. So this is an Android app that runs on your cell phone. You can point it at any sign, like a street sign, like the exit sign there, and it uses OCR capabilities to extract the text, and then it uses a machine learning model to translate it into your favorite language. That's so cool.
Wow, that's impressive. I remember reading last year where this particular application was one of the most downloaded ones during the Olympics in Korea. So if you can imagine walking around and everything's in Korean, how do I know what signs they're saying? How do I know what the menus say? So I heard that this was came in very useful for a lot of people.
Wow, I'm not surprised at all, Tony, because I tell you, whenever I visit Tokyo, this is my single most favorite product. It saved me many more times than I can think of. The other application of AI that I find really useful is in the data center. So our friends at DeepMind published a research paper showing how they significantly reduced energy consumption in our own data center. In fact, the published paper actually quoted a 40% reduction in energy consumption, which translates to a 15% improvement in power usage effectiveness. So this is huge, not just for budgeting, but it's also huge for the environment. And so Google's goal for AI is to democratize AI, because we truly believe this is a transformative technology for all types of businesses. But to do that, you have to solve the supply problem rather, right? Because today there are very few data scientists in the market. It turns out there are only about 1 million data scientists. And if you look at people with deep learning experience, they're down to the thousands.
Wow.
But in contrast, there are over 21 million developers around the world. So one way to democratize AI is to make it accessible to developers and enterprises so they can build the next generation of smart apps.
Information Week actually just published an article recently where they were talking about this shortage where there was just this number of developers and AI specialists, that there was such a shortage of them that they ended up having to go to contractors. So the contractors were charging a lot of money, so unfortunately a lot of people could not then afford to take AI and get it into their applications.
Yeah, that's a real challenge because you know, it's hard enough, as I said, to find good data scientists and ML engineers, but the economics makes it prohibitive for smaller companies, right? Because these contractors can be pretty expensive. Yeah. So Google works with many of our customers across the world to improve their business and in many cases to transform their business with AI. In the interest of time, I'll just talk about two. The first one is Ocado. Ocado is the largest online-only grocery store in the UK. And this is a very, very tech-savvy company that uses AI to transform the customer experience. So one of the cool things they did was to simplify the user experience by offering their customers just one email for everything. If you're happy with Ocado, send them an email here. If you have any billing issues or product defects, for instance, you send an email to the same address, right? That's huge to the customer, obviously, right? Because they don't have to fill out forms. But it can be a nightmare for the retailer, right? Imagine if they had to have human beings process every single email. It would take too much time and too many people. And so Ocado solves this problem with AI. They use a natural language processing model built with TensorFlow and running on GCP to process each email, understand the meaning, and then reroute the email accordingly.
Oh, interesting.
The second customer I want to call out is Rolls-Royce. And with Rolls-Royce, we're moving from autonomous cars to autonomous ships. So Google Professional Services has actually worked with the Rolls-Royce team in Finland to build machine learning models that will help Rolls-Royce with their goal of achieving self-navigating ships. And so they use ML, specifically TensorFlow models, to do things like object recognition, right? If you see an object in front of you, what are you looking at? Is it a ship? Is it a small sailboat? And which direction is it moving in? Is it going away from you or towards you, right? You have to make those decisions in real time because they're very costly.
Yeah, definitely don't want to have another Titanic on our hands, so I'm glad that technology's out there to maybe find icebergs as well.
Absolutely, absolutely. And so Google will achieve its goal of democratizing AI in 3 ways. The first is we provide building blocks that developers and machine learning engineers can use to build ML solutions, right? The second is a robust platform on GCP, the cloud AI platform that you can use to build scalable AI and machine learning models. And the third one is we provide solutions for very, very specific problems. So let's talk first about the building blocks. So the cloud AI team at Google provides a set of APIs that developers can use to build the next generation of smart AI apps, right? And you can build these apps for things like sight, language, or conversation. So for sight, we have the Cloud Vision API, we've got the Video Intelligence API that you can use to do things like image recognition or find specific objects in a video, for instance. For language applications, you can build smarter apps with things like the Cloud Translation API or the Natural Language Processing API. And then for conversation, we have Dialogflow Enterprise that you can use now to build intelligent chatbots. You can also use the APIs, the speech-to-text and text-to-speech APIs, to build speech-enabled applications. But the really interesting new addition to this lineup is AutoML, and that's what we highlight here in the orange circles. So what's AutoML? AutoML is a new product line from Google that automates the development of ML models. So if you have to build your own model yourself, you start with the data, you do the training, the testing, and deployment. But AutoML takes your data. It uses very smart machine learning algorithms on GCP, and it will build the right machine learning model for your data. When it's done, it gives you a REST API that you can call from your smart app. How cool is that?
Wow, that's really impressive. Because I know, like as you mentioned earlier, one of the big challenges is, number one, how do we get that talent? How do we get people that know everything from Python to R to so many different technologies out there in data science? How do we get those people that maybe have some real world business or industry experience? Finding somebody like that is probably like finding a unicorn in a field of rainbows. So, it sounds like this tool might help to bridge that gap.
No, absolutely, absolutely. This is the reason why the Cloud AI team built this new AutoML product line, because the supply of ML and machine learning talent is very, very tight in the market.
Yes, for sure.
And as we said earlier, it's also it's too expensive for some customers. And so with AutoML, they can go ahead and build their own models. And then this is how the end-to-end solution looks like on GCP. So to build an AI model, you start with your data that you ingest into the cloud, right? So in this case, you can ingest it either in batch or in real time. For batch processing, you can use our transfer service. For real-time data, you use PubSub. Once in GCP, you can pre-process that data with either Dataflow, which is a pipeline, or with Dataproc, which is a managed Hadoop service on GCP. You can store it in a number of places, but the most popular destination for AI modeling and data analysis is BigQuery, because BigQuery is a very scalable data warehouse in the cloud. Once there, we can start to build our machine learning models now with things like cloud machine learning engine.
That's great, because I know a lot of our customers out there are very loyal, love using BigQuery for a lot of their data warehousing needs. So perfect.
Absolutely. I haven't seen a better data warehouse in the cloud. And then before I continue, I wanted to just talk a little bit about this dedicated hardware we offer on GCP. It's called TPU. TPU stands for Tensor Processing Unit. We're now in the third generation of TPUs. And the reason it's so important is that it significantly speeds up your AI and machine learning workloads. The coolest thing about it is this TPU processor was actually designed and built by Google hardware engineers, and it's available only on Google Cloud Platform.
Wow, so the hardware really matters that much? Like if I'm running a model or training a model, like it makes that big a difference?
Oh yeah, absolutely. So if we look back maybe 15 to 20 years ago, machine learning and AI models were built using the standard CPU, right? But sometimes the training was too slow because for some workloads, the processing is too intensive, especially if you're using neural networks. But TPUs significantly speed up the performance, right? A good example is eBay. So eBay has a very cool and popular feature for visual product search. And behind that product search is an image classifier model. So in the past, it used to take them a couple of months to train one of those big models on premises. And that's because it needs a lot of data. They train it on over 55 million images. Wow. Can you imagine that? But with TPU, it's improved the training to the point where they now take only a few days to train one of those models. So a few days versus several months. So they've improved performance by more than 10 times. But the real bonus is that because it's a modern AI model built for TPUs, it actually improved performance by over 10% as well.
Wow.
Cool. So I talked a little bit earlier about some of the customers we've worked with. We're actually working with Google customers all across the world, across several different industries. But I just wanted to share some of the common AI and machine learning use cases we see. So for manufacturing, for instance, predictive maintenance is one of the most popular use cases. We also see a lot of interest in demand forecasting to help with planning. For retailing, demand forecasting is also pretty popular, but the other popular one is recommenders. So a lot of retailers are very interested in recommenders to provide personalized user experiences and also to drive cross-sell and upsell. In healthcare, I think we're about to see some pretty transformational applications of AI. One of my favorite ones, quite frankly, is a few months ago this year, the FDA approved the first ever device powered by AI for predicting diabetic retinopathy.
Wow.
So basically this machine can predict if a patient is likely to develop diabetic retinopathy before it happens. And that's huge because the impact is it can actually save a patient from blindness.
Wow, that's impressive.
Yeah. So in the interest of time, let me move on, and I want to talk about one particular use case, which is predictive maintenance. Before we go too deep, just imagine if you could predict, which vehicle will fail in a car park like this before it does, right? I would certainly want that on my car, right? Or imagine if you could predict how much time is left on your device, whether it's a thermostat at home or some other device in your car. Those are common examples of predictive maintenance problems. And there are many more goals we see why people do predictive maintenance. If we just talk about a few of them here, one of the commonest ones is just to predict, will this piece of equipment fail by the end period? Say, can it fail in the next month or two? And if so, why? What's the cause? Another common one is, how much time do we have left on a particular device? Then sometimes when people do predictive maintenance, they're trying to identify anomalies. Because typically, your equipment, a functional equipment typically operates within a certain tolerance level. And so when it goes beyond that tolerance level, that's usually a sign of trouble. So anomaly detection can be used for that. Then some manufacturers use predictive maintenance for yield management, basically quality management. So if you imagine a product going round an assembly line, right? It has multiple stations, and at each station we have sensors taking various measurements. So it turns out that you can build machine learning models that will take that data from all of those sensors and start to predict if this particular product going round is likely to be defective.
Wow.
So that's another use case
That's
for
interesting, because I was working with one customer, and they had a whole fleet of vehicles on the road, and they were actually using sensors on those vehicles to see, basically track everything through this IoT, and then they take that IoT data, feed it into predictive models to find out, hey, should I pull that off the road before it breaks down and maybe jeopardizes my supplies getting to where they need to be. So
and it's also
interesting.
Yeah, and it's also very good customer service, right?
Exactly.
Because if you predict failure beforehand, then you can actually call the car in for servicing before it actually breaks down.
Absolutely. I wish my car had that more than once.
That makes two of us. So I just want to show a small demo here to actually show what you can do with predictive maintenance. So here's a dashboard from an aircraft manufacturer, and they have 3 sites around the world. This is where you see the airplanes in the US, in Turkey, and in the Gulf, right? Then we have a dashboard here showing the remaining lifetime for each component. So what's that about? So if I click on one of the planes, let's click on the one in the Carolinas, you'll see it's giving me a warning. Ooh, where's that coming from?
Glad I'm not on that one.
Okay, so what's happening here is we have one piece of equipment that's taking measurements. So if I click on that one, we'll see more details. You see it measures things like the exhaust nozzle pressure, right? Maybe it's measuring it with a barometer or a pitot-static tube. It has a thermometer measuring the inlet temperature of the air coming into the equipment. There's another sensor measuring fan speed. Now, when it's okay, you see the sensor shows green. But when we see amber, it means something is wrong, and that's why we're seeing a warning here, because it's saying this machine is not operating. So some of the sensors are not operating within their correct thresholds, right? And that's why it's issuing an error, a warning sign there, and it's telling me, ooh, we have very little time left on this particular device. So in this case, it's a turbine.
Yeah.
So this is one real application of predictive maintenance, how you can actually use all of that data from the sensors to predict which particular equipment will fail before it does.
Yeah, so once you get that prediction at that point, you can do things like schedule the maintenance, maybe even tie it into, let's say, some kind of a back-end ERP system that's going to say, oh, it needs maintenance, but do I even have the parts in my warehouse? So you could kind of put it in the whole value chain.
Yeah, and it's huge for an aircraft manufacturer or even an airline, right? Because if you think about it, the cost of unplanned downtime is very, very high for them. Very high.
I think we've all been stuck in an airport with some unplanned downtime.
And it's not even funny.
Exactly.
Yes. No, but it costs a lot of money for each of these operators.
Yeah.
And it also creates customer dissatisfaction issues for them. So if they can predict failure before it happens, it will save them a lot of money and buy goodwill with customers. So let's look at the architecture here. If we just look under the hood behind this predictive model, what's going on? So here's the logical architecture. At a logical, in a logical level, it's very, very simple. You have 3 steps. The first one is you have to ingest your data from different sources. So in our case, we're ingesting the data from all of these sensors, whether it's the pressure sensor or the thermometer, right, or the speedometer reading the speeds. You ingest it. Then the second part is you have to process that raw data, because you need to do some pre-processing to prepare it for machine learning. Once you're done, then you can build machine learning models. So if we double click on this, this is what the more detailed architecture looks like on Google Cloud Platform. So we ingest the raw data from the sensors, right? So data is coming in, and the way we capture it is through our Cloud IoT Core product on GCP, right? So this is an IoT gateway that collects data from different sensors.
Gotcha.
Then we can push that data into the cloud using PubSub. In this case, we use PubSub because we're streaming all of that data in real time. We also build you can use PubSub for streaming. You could use data flow, but in this case, we don't use it because we're streaming the data. Next, we load the data into BigQuery, and then we use Cloud Machine Learning Engine to train machine learning models that we then deploy on GCP. From there, it serves the models through data flow, and then we can also visualize the model using different tools. In this case, we actually visualize the model using Data Studio. That's all I planned today for my presentation. Thank you very much.
And many thanks for joining us today, but don't go anywhere. We've got more great sessions coming right up. We really hope you enjoy the conference.